Hello, this is Ms. Russell. Today we're going to be learning section 6.1, exponential growth and decay functions. Our objectives for today, the first one is to be able to graph exponential growth and decay functions. The second objective for today is to use exponential models to solve real-life problems. So exponential functions, they have the form y equals a times b to the x, where x cannot equal 0, and the base b is a positive real number other than 1. Exponential growth in particular has an a value that is greater than 0 and a b value greater than 1, and b is called your growth factor. We're going to look at both parent functions for exponential growth and decay. So first, exponential growth, we're looking at a function where f of x is equal to b to the x. So this will be our parent function. And here, because it's exponential growth, we're looking at where b is greater than 1. And so there are a couple things that you'll notice. I'm just going to tell you some characteristics of exponential growth functions, and then we're going to actually graph it. So b is greater than 1. Our graph is going to rise. So rises from left to right. And also it's going to pass through, so passes through the point 0, 1 and 1 comma b. And then something else to note about this function is that y equals 0. So the x-axis is an asymptote. All right, so let's graph our function. So we have this asymptote here. And we have a point at 0, 1. And then depending on what b is, we'll have another point at 1, b. So 1, b, it could be anywhere really. Let's put it up here, I don't know. And so you're going to draw a curve that passes through these points and does not cross your asymptote. So it should look something similar to this. Okay, next we're going to draw the exponential decay function. So exponential decay, for this one, we still have the function f of x equals b to the x. But here we're not looking at b values that are greater than 1. We're looking at b values that are between 0 and 1. And for decay, the graph falls from left to right. And it passes through the points. Zero, 1 and 1, b. So it's going to pass through point 0, 1 and 1 comma b, but its shape is going to be in the other direction. Oh, and this one also has an asymptote at y equals 0. So your graph will never pass that. Okay, so some of the problems you're going to be doing will involve graphing. So first of all, you want to, for example 1, tell whether each function represents exponential growth or decay, and then graph the function. So to see if it represents growth or decay, we're going to look at our b value. So in this particular example, is b greater than 1, or is b between 0 and 1? So our b value is 2. 2 is greater than 1. So this is going to be exponential growth. In order to graph this, I just chose some x values that are to the left and the right of the y-axis. And all I'm going to do is plug them into my calculator. So if I have -2, then I have 2 caret and then -2. And that gives me 0.25. And you're going to continue to do that, right? So you're going to put in -2, -1, and so on. So you should end up, I'm going to put them in fraction form. So you'll have 1/4, 1/2, 1, 2, and 4. So now you have some ordered pairs that you can graph. So let's see. I've got, let's see, I go up to 4. Okay, so -2 and 1/4 is about here. -1.5 is about here. 0, 1, 1, 2, and 2, 4. And then just make sure it matches what you said, right? We said this is exponential growth. Does it look like exponential growth? Yes, because it's rising from left to right. All right, and now we're going to do another example. So we're going to do part B. I'm following along with the actual examples that are in the book. I figured it'd be easier that way. If you needed to, you could go back and look at the book. All right, so this one is B, or part B is y equals 1/2 to the x. So this one, your b value is between 0 and 1. So this one will be exponential decay. Okay, so again, I just chose the same values. I'm going to plug them into my calculator. And I have that when I plug -2 in, I should get 4. -1 should be 2, 1, 1/2, and 1/4. So I'm going to plot these points. At -2, I'm at 4, -1 and 2, 0, 1, 1, 1/2, and 2, 1/4. So you're just going to curve through the points. And again, you're going to go toward your asymptote, but you're never going to cross it. And this matches with what I said this graph should be exponential decay. Moving on from graphing, we're going to look at exponential models. So, exponential growth model. There are two types here. So one equation is y equals a times 1 plus r to the t. And the other one is y equals a times 1 minus r to the t. So this one gives you a growth factor, it's 1 plus r. This one is a decay factor, 1 minus r. A is your initial amount. R is your percent increase or decrease, and it is always written as a decimal. So if they give you a percent, you need to change it to a decimal. So we're going to move on to example 2. I have it all written out already. You might want to copy it down, pause the video for a minute. So we're solving real life problems now. Remember, that was one of our objectives. Example 2, the value of a car in thousands of dollars can be approximated by the model y equals 25 times 0.85 to the t, where t is the number of years since the car was new. So this has 3 parts to it. A, tell whether the model represents exponential growth or decay. So again, remember we're looking at that b value. So in this case, our b value is between 0 and 1. So this is going to be exponential decay. Part B, identify the annual percent increase or decrease in the value of the car. So if you remember, our formula for exponential decay was y equals a times 1 minus r to the t. The equation that they give us in the problem is y equals 25 times 0.85 to the t. Okay, well, a is 25. My 1 minus r is 0.85. If I'm looking for the percent increase or decrease, in this case, obviously, it would be a decrease because we're looking at decay, I need to figure out what my r value is. So 1 minus what is going to give me 0.85? 1 minus 0.15. So in this case, my decrease is 0.15. So my annual percent decrease is 0.15 in decimal form, or 15%. Part C, estimate when the value of the car will be $8,000. So the value of the car is going to be our y value for this function. And so if you get out your graphing calculator and you hit your y equals and you plug in your function, we're going to go to the graph and then hit trace. And we want to move left or right until we see a y value that's close to 8. So I was already kind of there. The closest one is actually going to be when x equals 7. So our x value in this case is actually t. Right? It's our time, which is what we're looking for. The other way that you could do this is to do second graph. It'll give you a table, and you can look for the y value that's closest to 8, and then the x value that matches up with that will be what you're looking for. So in this case, part C, you use your trace function on your calculator or your table, and then you approximate where y is 8, and it's about at when x equals 7. So it'll be 7 years. All right, we're gonna go to example 3. Again, you might want to copy this down, pause the video. So this time we're going to be writing an exponential model. So they're not giving us the function. In 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by about 1.18% each year. Write an exponential growth model giving the population y in billions t years after 2000. Estimate the world population in 2005. All right, so first of all, we have to look at all the information they gave us. So it tells us that the world population is 6.09 billion. So that is our initial amount. So if you remember, right, first of all, this is a growth model. So for part A, we're going to be looking at y equal to a times 1 plus r to the t, where a is going to be 6.09 because it's our initial amount. And then we also are given this percent increase each year. So that's going to be our R. But R, remember, we don't want it written as a percent, so we have to change it to a decimal. So it's going to be 0.0118. All right, so let's write our function. So y equals 6.09 times 1 plus 0.0118 to the t. And then we're just going to simplify. So y equals 6.09 times 1.0118 to the t. That's it for part A. Well, for writing the function anyway, I forgot. So here they also want us to estimate the world population in 2005. So t is the number of years after 2000. So in this case, t is 5. So y equals 6.09 times 1.0118 to the 5th power. So I'll show you how to put that in your calculator. So 6.09 times 1.0118, and then again, you're just going to use this caret key to the 5th. So you should get, if we round to the hundredths place, 6.46 billion. So it's approximately 6.46 billion. B. Okay, so for part B, we're going to estimate the year when the world population was 7 billion. So we're going to use the table feature for this one. So you're going to go to your y equals 6.09 times 1.0118 caret x. And then you're just going to go to second graph. And again, we're looking for when the population is about 7 billion. So we want to look for where our y is approximately 7. And it looks like we need to go down further. You can just use the arrow down button. So it looks like the closest one's going to be when x is 12. So x is our t value. So x equals 12, right? But we want to know the year specifically. Well, 12 is just how many years we are after 2000. So really our answer is going to be 2012. Okay. Example 4. Almost done. One more example after this. All right, so the amount Y in grams of the radioactive isotope chromium-51 remaining after T days is Y equals A times 0.5 to the T over 28, where A is the initial amount in grams. What percent of the chromium-51 decays each day? So we're looking at exponential decay. So y equals a times 1 minus r to the t. All right. Oh, just kidding. They give us this. So here they give us y equals a times 0.5 to the t over 28. And so we're looking for our rate, right? We're looking for our R value. So the first thing that we have to do is we have to get rid of this denominator in our exponent. So we're going to use the power to power rule. So we're going to have that y equals a times 0.5 to the, we're going to break this up into 1 over 28 to the t power. I'm going to put in my calculator what 0.5 to the 1 over 28 is. So that would be 0.9755 to the t power. And then if I rewrite this, it'll be y equals a to the 1 minus 0.0245 to the t. Because I'm looking for what this can be rewritten as to get 1 minus something. So the rate of decay is 0.0245, or in decimal, or in percent form, it's 2.45%. One last topic we're going to talk about is compound interest. So that's a whole nother formula. It's A equals P to the 1 plus R over N to the N times T. So P is your principal amount, R is your rate as a decimal again, N is the times per year, and A is the amount in the account after T years. So we're just going to do an example of this. Example 5. You deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. So first of all, we have to think about what that means. If something's compounded quarterly, that means it's 4 times a year. So quarterly means 4. And we're going to start with our equation. A equals P times 1 plus R over N to the NT. And we know we're going to use this equation because it's talking about interest. So our 9,000 is going to be our principal amount. So A equals 9,000 times 1 plus our R value is the rate, so it's 1.46, but again, it has to be written as a decimal, so 0.0146. And our N value is 4, because we said that it's compounded 4 times a year, and N is the number of times per year. And then again, we have N up here, 4 times T, which is the amount in the account, or no, sorry, T is the time, right? So that would be 3, because we said it's 3 years. I think I forgot to write T on our last one. If you go back to your equation, T is the time. Okay, sorry, I missed that. All right, so you're just gonna put this in your calculator, and you should end up with A being approximately $9,402.21. All right, make sure you contact me or your specific teacher if you have any questions. Thank you.